We are going to begin our quadratics unit with reviewing how to complete the square. No, none of them. And so if you guys think back to grade 10, when we were learning about the parabola, we learned about the parabola in a formula, in a form that was called vertex form. However, since then, we have learned two other forms, which are standard form and factored form. So today, we're just going to be practicing how to convert from one form to the other, and also gathering up information based on those different forms. So you know how we were learning how to graph parabolas? Whenever we did that, we had something called vertex form, and this is the best way to graph a parabola. It tells you your horizontal translation, your vertical translation, your stretch, your compression, all of that stuff. And then you can use a step pattern and graph it. However, you're not always given a question in vertex form. Sometimes you're given it in standard form, and you have to learn to convert standard form to vertex form in order to be able to answer the questions a lot easier. So we're going to go through a series of examples. I'm hoping it's going to jog your memory from grade 10, and for some of you, it might be brand new, in which case you're just going to have to work a little harder to review this stuff tonight. Okay, so what we're going to do to start off this question is we're going to group the first two terms together. Now we're starting off with the easiest example, which means once we've grouped those two terms together, we really don't have anything else to do. In the next example, you're going to notice there's going to be a number in front of the x squared. And whenever there's something in front of the x squared, you would have to factor it out. But this is an easy example. There's no number in front of the x squared, so we really don't have to do anything else. Now we're ready to complete the square. And what that means is you find the number that is attached to the x, which is a 6, and you do the following to it. So you're going to take your positive 6, and you're going to divide that by 2, which gives you a 3. You're going to take that 3, and you're going to square it, which gives you a 9. And this process is actually where the word completing the square comes from, because that is completing the square. Yes. Say that again? Yes, exactly. Okay, so now we have completed the square and we have a positive 9. Now we need to do something with that. So we're going to write y is equal to x squared plus 6x. And the number we just calculated when we completed the square, we are going to add that with our 6x. We're going to close the brackets. And we're going to say to ourselves, we can't randomly add a number to an equation without changing the value of that equation. That's not allowed in math. You're not allowed to just go ahead and add numbers. So how do we balance that out? If we've added 9, what can we do to balance it? Good. So we're going to subtract 9 right after. And I put square brackets. Now, this is a personal preference. When you learned it in grade 10, perhaps your teacher did not use so many brackets, and you can use that method if you like. I just like when things are organized nicely. So for me, I put my positive value inside the rounded bracket, and I put my negative value inside the square bracket. And that way I can see everything really nice and easily. So Bea asked before, what's the point of doing this? The whole purpose of doing this is inside the rounded brackets, you should now end up with a trinomial that is a perfect square trinomial. And the significance of that is when you have a perfect square trinomial and you're trying to factor it, you end up getting factors that are exactly the same. So I'll just illustrate that here. We're going to have x times x, 3 times 3, plus and plus. And we can rewrite that to be x plus 3, all of it squared. And that's really the whole point of completing the square. You're trying to get a trinomial that is a perfect square trinomial that you can factor and get 2 of the same factors. So now we're going to go back to our question, and we are going to replace that rounded bracket with x plus 3, all of it squared. So all I've done is I've taken this and just factored it to get that. And everything else stays the same. So we have a -9 and then a +8. In this question, the square brackets are insignificant because there's no number in front of them. So really our last step is going to be to open up all of the square brackets. So we're going to get x plus 3 squared, and then negative 9 plus 8 is negative 1. And that's our final answer. So we have gone from standard form all the way to vertex form. And this is beneficial because vertex form now allows you to graph the parabola. You can figure out what the vertex is, the axis of symmetry, the maximum, the minimum, all sorts of stuff. So it's a very useful form for it to be in. We're going to do this about 3 more times. So if you still have questions or concerns, just wait till the second example and then I will answer them. In my previous class, everyone was like, why does the cat look like that? But it's because it's completing the square. The theme is square, so everything is square based. It's not like a flat cat. All right, let's try the next example. We have y is equal to negative 3x squared plus 6x minus 1. Okay, I begin this question by first grouping my first 2 terms together. Is my x squared by itself in this question? No, so I'm going to have to factor it out. Do not factor out the x. Even though the x is common between both of them, you don't need to factor out the x, just the coefficient. Okay, then we are going to take the number that's attached to the x, which is our negative 2, and we're going to complete the square. So I'll walk you through the process again. We start with negative 2, and we divide that by 2, which gives us negative 1. Then we take that negative 1 and we square it, which gives us a 1. So that 1 is the number we're going to be adding and subtracting inside and outside of our brackets. Yes? Oh, it's just right. Okay. Thinking about it. So we're going to have y is equal to negative 3 x squared minus 2x. None of that changes. I'm going to add the 1 over here and close the rounded bracket. And then I'm going to subtract the 1. And again, personal preference to just put square brackets around all of that. And then a minus 1 on the outside because that was part of the question. At this point, all of the stuff inside of the rounded brackets is a perfect square trinomial. So you can do the work on the side if you want. If you can kind of just visualize and see it, you can write the answer straight away. But that's what I end up with. Okay, now here is another important part of the of this question. We have a negative 3 on the outside, and we have to distribute it to every single term inside the square bracket. To do this, what I'm going to do is I'm going to take that negative 3, and I'm just going to attach it to x minus 1 squared. I don't need to like distribute it inside the bracket or anything like that. You just take the number outside and stick it on with the number, with the term that you just factored. And then remember, we're also going to take the negative 3 and multiply it to the negative 1. So negative 3 times negative 1 would be positive 3 minus 1. And as our final step, we are just going to collect those constants, the like terms. We're going to get negative 3 bracket x minus 1 squared plus 2. And that would be our final answer. Okay, so even though we have a fraction, really the steps don't change. We are going to group the first 2 terms together. We are going to factor out the half. And we're going to think. Now, remember, we did this when we were doing our transformation. So you guys are somewhat familiar with this. A half times x squared gives you a half x squared. A half times what is going to give you a negative 1? Good job. Yeah. So this is going to be negative 2x plus 3. Now we use logic there. If you actually wanted a calculation, it's whatever this number is over here, like negative 1 divided by that number would give you this number. So negative 1 divided by a half would be negative 1 times 2 over 1, which would be negative 2. And that's sort of how you get this number over here. But often for these types of questions, you can use logic and figure it out that way, because I won't give you like crazy fractions. Okay, the rest of the steps are exactly the same. We're going to complete the square with this negative 2. So it's going to be negative 2 divided by 2, which is negative 1, all of it squared, which is a 1. So y is equal to a half x squared minus 2x. I'm going to add a 1 here, and I'm going to subtract a 1 here. And I put square brackets around all of that, plus 3. This trinomial is a perfect square trinomial. So you can just go to the side and figure out what that would be. So for this step, all I did was I factored from there to there. Now, if you were confused what I did in the last question, I'll just show it to you again. I'm going to take this half and I'm going to distribute it here, and I'm just going to glue those on, and then I'm going to multiply the half and the negative 1. Okay, so this step is the distributive. And you only have to do this when you actually factor out a number. So in the first example, we didn't have to do this because there was no number attached to your x squared. And that's what I get over here. So you guys, the next question is interesting because it says challenge, and in grade 10, this would be given to you as a thinking question, kind of. But now in grade 11, we're expected to do it. And at first, it seems like deceivingly easy because you're like, well, what's so difficult about it? But when you get into it, you're going to notice you're dealing with fractions. So let's try this question. Blue, purple, let's do orange. So I'm going to have y is equal to, I'll group the first two terms together. And then when I'm completing the square, I'm going to complete it with the negative 1. So negative 1 divided by 2 is not going to give you a whole number, which is why this is a little bit of a challenge. We're going to square that, and we're going to get 1 over 4. So now we're going to take that, and we're going to add it inside of the bracket. And we're going to subtract it outside of the bracket. We're going to put square brackets that are really irrelevant, but my OCD cannot drop them. I have to include them, so I will. Now, factoring this is, again, a little bit tricky. I'm just going to go to the side to show you how I would factor it. I have x squared minus x plus a quarter. And I know this has to be factorable, right? Because part of completing the square is it gives you two of the same terms. So I think to myself, what two numbers multiply to give you a quarter, but when added together give you a 1? Marzouk? A half, yeah, good. So a half and a half, minus and minus. And now usually if you got a question like this in a factoring test, it would be tricky. But because we know it has to work and it has to be the same two factors, you can figure it out. So when I go back over here, I'm going to have x minus a half, all of it squared. And we can finish off the question. This would give me, I guess this time I'll just do it in improper fractions to just show you that it doesn't matter. You can have it either or. For sure, yeah, 2 3/4, yes. Okay, and the last question on this page, it is Again, this is a question I always give on my grade 10 test for this unit. And it really messes with people because you've been completing the square for so long, you forget what the question is actually asking. It's saying convert the vertex form to standard form. It's already in vertex form. So what do you think I have to do to convert this to standard form? Work backwards. And that means we're going to expand. And that's really it. So all I'm going to do is I'm going to take this y. I'm going to write it as x minus 2 times x minus 2. And it's basically going to involve foiling, distributing. If you're wondering if that's SpongeBob, someone else also asked that. And no, it's just a square because it's completing the square. What part of this guy looks like a sponge? This is the Walmart SpongeBob. You guys are right. Never again am I going to have themed diagrams on my sheets. You guys were hating on my square cat. I see my little square here. All right. I'm going to stop this here. And that's the end of completing the square.